All right, let's start right at the foundation, bitrate, or if we're using the original German term, Datenübertragungsrate. This is simply the data volume transmitted over a channel within a specific time period, and it's measured in bits per second. To really lock this into your brain, let's use our never forget visual analogy. I want you to picture a water pipe. Bitrate is the total volume of water steadily flowing out of that pipe every single second. A wider pipe or higher pressure just means more water, or in our digital world, more bits flowing through per second. Simple enough, right?
Now let's contrast that with latency, or Verzögerung. Latency is the actual time duration it takes for an element, like a signal edge or a whole data frame, to travel from the sender all the way to the receiver. Going back to our water pipe analogy, if bitrate is the massive volume of water flowing out of the pipe, latency is the exact amount of time it takes for one single specific drop of water to travel all the way from the source reservoir to the very end of the pipe. You can have this huge pipeline delivering a massive volume of water, but if that pipe is miles long, that first drop still takes a significant amount of time to actually arrive.
To put that into perspective, think about a standard 50-meter twisted pair wire. If you measure a pulse between the start and the end of that specific line, the delay is exactly 287 nanoseconds. Do the math and you get a physical delay of 5.74 nanoseconds for every single meter of cable. And remember, that's just the wire itself. You still have to add all the delays from the protocol controllers and the transceivers on both ends. So keep this in mind. Latency is completely independent of your bitrate.
Okay, so we know that our drop of water takes time to travel, but what if it doesn't arrive exactly when we predict it will? That brings us to jitter. Jitter is the stochastic, or basically unpredictable, fluctuation in the transit time of your signal edges. Imagine your water pipe again, but this time the water pump is stuttering. The pressure is spiking and dipping slightly. The drops of water are definitely still arriving, but their exact rhythm is totally unstable. As you can see, you might have an ideal, perfectly timed signal, but jitter creates this band of variance where signal edges arrive slightly earlier or later than that perfect timing. Things like electromagnetic interference or slight clock deviations create this jitter, and any robust system absolutely has to be designed to tolerate it.